Hi, I'm Stefan Alfredsson, and this video will introduce the practical assignments in the COW DVAD63 Multi-Access Solutions course. So the outline of this presentation is that we'll talk about the experiments. What are we doing? Why are we doing this? We need some software to install on your computer to run an emulated environment called Mininet, and we'll also have a walkthrough of Mininet and show you how to run the experiments and see the output data. So the overview of the experiments is that we have seen that mptcp is capable of aggregating capacity over multiple paths. And this works well with the symmetric paths, but with path asymmetry there are some scenarios where we don't get so good performance. So we will test this in an emulated network environment. So we will both show the gains that we get by link aggregation, and we'll also see what can happen if we have path asymmetry on the effect on the throughput. So the emulated environment consists of a virtual machine. To run this, you will need the VirtualBox software, which you can find on www.virtualbox.org. Then we have prepared a virtual machine image, which is basically a Linux Debian installation with an mptcp kernel and the Mininet installation. And you can find those files to download at the link cowbox.com. When you have downloaded and configured the virtual machine in VirtualBox, you start it, and then you use DVAD63 for the username and password. So I will show you how this looks like. So here we have the login screen, DVAD63, DVAD63. So the display you are greeted with three icons: Mininet, Mininet Asymmetric, and Mininet Asymmetric TCP. We'll go through shortly what these do. So as I've shown you, you have the desktop with the Mininet icons, and when you click on this icon, you will start the Mininet emulator with a configured network environment. If you would like more information on Mininet, how to do custom configurations or do this setup on your own computer, you can see the website at mininet.org. So to run the experiments, we will configure a virtual environment. In this case, we have a client and a server, and they are connected. The client is connected with two paths and the server with a single path. So the client has two symmetric paths of 40 megabit and 5 millisecond delay each. And you can also see on the slide that we have two addresses on the client side, and on the server side we have a single address. And the server is connected with 100 megabit and 5 millisecond delay. So if you click the number 1 Mininet in the virtual machine, you will start an emulation with this scenario. So we see that Mininet has started, and we get a Mininet prompt here. Then we will start two terminals on the two hosts, host 1, host 2, H1, H2. And then we will start a third terminal on host 1. Xterm H1, H2, Xterm H1. So in these windows on H2 we have the server, and then we have the client, and we have another one with the client. So as you see in the instructions, we will then start the IPperf3 server in the H2 terminal, and in the H1 terminal we'll start the iperf in client mode and connect to the server. And we'll run this for some time, 360 seconds. We don't need it to complete, but just to have a continuous flow of data. So H2, iperf3 server, and on the client we'll run iperf3 client 10.0.22. And here we see that we have some data transferred. So we see that the bit rate is around 70 megabit per second. Looking at the link configuration, we saw that we had 40 megabit and 40 megabit on each of the two links. So aggregating this should then in theory yield 80 megabit per second. We get a bit below this, partly from the emulation environment, and that I'm also running the screen capture software at the same time, so I get a bit degraded throughput. We can also run a software called speedometer. This is what we'll use for the second H1 terminal, and this will then show you how the traffic is passing over the interfaces. So on the upper part you will see host 1 ETH0, and on the bottom part host 1 ETH1, and you can see that we have around 35 megabits each, which would then sum to around 70 megabits in total. So let's stop the experiments, go to the mininet and just type exit. So now let's look at path asymmetry. As we talked about earlier in the course, if we have multiple paths, it's not good to use both with mptcp if one of them is very bad or if they are highly asymmetric. So using the mininet asymmetric icon on the desktop, you will configure this topology where we have one of the interfaces on the client dropping from 40 megabit to 1 megabit and increasing the delay from 5 millisecond to 50 millisecond. And we'll redo the same experiments and we'll see what performance we get. So as before, we start the Xterm H1, H2. And if you want, you can also open a third terminal to watch the speedometer. And then we'll run, like before, the same commands with the server and the client to initiate the transfer. So now remember that we have one 40 megabit and one 1 megabit. So aggregating this in theory should give us 41 megabit per second. Machine, click on the mininet asymmetric icon. Start the terminals, Xterm H1, H2. In H2 we run the iperf3 server, and on the client we again run iperf3 client 10.0.22, and now we'll run it for only 10 seconds. So remember, the expectation was to have aggregate capacity of 41 megabit. And already here in the bitrate we see that we have quite less. And in the summary we have around 11 megabit per second compared to the expected 41 megabit per second. We can also have a look Xterm H1 with the speedometer and see. Let's repeat the experiment. You see the two interfaces. And we are fully utilizing the 1 megabit link, but the other one is only utilizing a much lower capacity than the configured 40 megabit. So why is this? So the problem is with mptcp and the scheduling of packets. So when we have this path asymmetry, we will get packets scheduled on both links, but we will experience head of line blocking, we will experience packet reordering, and with this asymmetry, these effects will be so grave that they will reduce the overall performance. So what is next? Revisiting the instructions, we have now seen the aggregated throughput and it was quite a bit lower than expected. Let's rerun the experiments, but using the Mininet asymmetric TCP setting, the last one. So the only difference between experiment 2 and 3 is that we are now using a single path instead of using mptcp. So in a sense, this is disabling the mptcp feature in the kernel. Let's exit the emulator and start number 3. Start Xterms again. Host 1, host 2. And on the server side, iperf3 server. And on the client, iperf3 client 10.0.22. Let's run this for 10 seconds again. And while the experiment is running, we can observe the instantaneous bitrate, and the summary lands at 36 megabit per second. So this is quite an improvement over the 10 to 11 megabit that we saw previously, and also quite close to the configured link capacity. Again, a bit lower than the expected 40 megabit per second because of the performance degradation in my computer and the screen recording. You will hopefully get somewhat closer to 40 megabit per second on your computer. So now that we have looked at this configuration, you can also try your own customized network settings if you would like. So the code is in the software directory, where you will find Python scripts. And you can change various configuration with the capacity and the delay and the buffering. You can disable, enable mptcp. And you can also change, for example, the scheduling algorithm that is used and see if that would make some difference. So what you do is you exit the terminal, you start just a generic terminal, go to the software directory, and here you can run sudo python test mptcp py. And then this is just the same as you would click on the icon. And in this script you can then configure the bandwidth, the delay, queuing size to some other configuration. And here you have the commands if you would like to play around with the different mptcp schedulers and see how that would impact. So thank you, and this is all for now. Bye.